Okay, so let's take a look at this example. We're going to use this one example and go through multiple subparts of it. So recently, a group of adults who swim regularly for exercise were evaluated for depression. It turned out that these swimmers were less likely to be depressed than the general public. The researchers said the difference was statistically significant. So, what does statistically significant mean in this context?
Yes.
What?
In our psychology assignment today, we were talking about something being
Yeah, there were
statistically
studies and it was like
significant.
it's statistically significant.
So, what does that mean?
It's a good question. It's a good question. I think you should
It's
answer that
probably
question, David.
significant.
So, what it means is that the difference in the percentage of swimmers who were depressed and the general public who was depressed is so large that we are convinced that it could not happen by random chance. That's what it means to be statistically significant. That it's so unlikely for that to happen by random chance that we believe it couldn't have happened by random chance. Okay?
Certainly cannot happen
You know, if someone came in and flipped a quarter 25 times and it came up heads every single time, we'd be like, the odds of that happening are so small that we don't believe it happened randomly. We believe either the person was cheating or that it's a weighted coin or something. Okay? So, a local newspaper wants to run a story with the headline Study shows swimming prevents depression. Comment on this claim as fully as possible. Anytime you see as fully as possible, that means you need to say more than like 10 words. Okay? So, what can you say about this? And some of this was on the homework last night, so what can you say about it? Yeah.
It's not an experiment, so I can't say it prevents depression.
Right. Because we cannot say there's any causation. Exactly right. So,
That's really wrong.
as this is a study, and not an experiment, we cannot conclude that swimming, and I usually like to use the word causes somewhere in there. So I would say it's a little bit awkward to word, but I would say swimming causes people to be less depressed. It only shows an association. So that's a good start. But when it talks about as fully as possible, you should talk about other things as well. This is sort of, you know, rote. Yeah, it's a study. We know it can't prove causation. So what else might we want to say? So this is where you want to speculate. So what may actually be a cause for people being less depressed that these swimmers have?
General fitness.
Okay, it may be that better general fitness causes less depression and not swimming specifically. And you could spend some time, what else could you think of that might cause these people to be less depressed? So they're likely to be better fit than the general public, or it could be that they are. I don't know. They may be, you know, doggy paddling and not really getting a lot of exercise. So part of it is at this point, you have to think more like an adult for a moment. So if you are swimming regularly, what sort of things have to be true about you or back it up? What is it you need in order to swim regularly? You got to have a pool, right? Either you personally own a pool, which likely means you're probably more financially well off, or it could be, all right, I'm going to the Y, but you're still having to pay for that, right? You have to have the wherewithal. A lot of these things come back to money. You have to have the wherewithal to, you know, either own a pool or be able to pay for some other pool on a regular basis. And that likely means you have more money. Maybe it's more money makes you happy. It doesn't. But, you know, that's a whole nother thing, right? We're just speculating some. So you could, we're not going to write that one down, but you could write, there's several things that you could write. And again, part of it is you have to be in the mindset of an adult. You know, when you think about these things, as a student, you don't normally think a lot about money. At least I didn't when I was growing up. Except for the time that we used to always buy bread from the day old bread store, and I asked my mom if we were poor once, and we got better bread after that. Score. The day old bread store was fine. There was nothing really wrong with it, but you know, when you're younger, you don't really think a lot about money or the lack thereof very often. As you get older, you think about it a lot. Okay? All right. So I would go on to say, no matter what example you gave, we could have given the money one, we could have given this one. I would say something in order to prove causation. We would have to perform an experiment. And what is that makes something an experiment? What is the one thing?
Having a control group.
Okay, a control group is something that we typically want to have. What is the thing that causes something to be an experiment and not a study?
Independent and dependent variables?
Pardon?
Independent and dependent variables?
No.
Okay.
I'll give you a hint. The first word is random. Assignment of subjects to treatments. That works. All right. So you work for a gym that does not have a pool. It's all those poor gyms. You wonder if anaerobic exercise, like weight training, is as effective as aerobic exercise, like swimming, or whether there is no causal relationship at all. Design an experiment using 120 volunteers currently not in a regular program of exercise. And then they ask, can you make this experiment single blind? And how about double blind? So let's talk about how we're going to design our experiment.
Okay. That is, well, wouldn't you
Randomly select and assign people.
Okay, so how are we going to do that? There's several ways that you could do that. What are you going to do to assign them? And what groups are we going to assign them to? Let's talk about that also. What groups are we going to assign them to?
Aerobic exercise and anaerobic exercise.
And you brought this up earlier when I asked what does an experiment need?
And a control group.
A control group. So we probably want one that is going to continue not to exercise.
Oh yeah, I want to be in that group.
Now, if we want each of those to have the same, if we use a random number generator for this, it doesn't work real well because what can happen is one group can have more than another. You're just throwing out statistical words at this point. So let's say that we wanted there to be an equal number in each group. How could we guarantee that there would be an equal number in each group? And it's the simplest form of random assignment.
Simple random sample.
What's the one that I told you guys? It doesn't take any technology. You just need some paper
Oh, with the hat.
and a hat.
That's what we were saying.
Yeah.
That would be too many people.
So, what are we going to do then?
Well, write everybody's names down on a piece of paper for the hat. And
Okay, now before,
Give them all numbers.
are we going to write their names down?
Oh, well.
Well, we could. There's two different ways you can do it. So if you wrote their names down, how would you go from there?
What if there's like 3 players and they're all playing?
No. We're not going to get silly about this.
Well, if we're, well, wouldn't you just like do 3 groups and then you just like pick one group?
Oh
You know,
yeah,
like
you have your like control exercise like press you like go in order of drawing.
Okay, one way to do it would be to write everyone's name down on equally sized pieces of paper,
And then shake it.
right? You got to mix it thoroughly. And then you could pull a name out. That person goes to the control group. The second person goes to the swimming group. The third person goes to the weightlifting group. And then repeat over and over.
Yes.
You could do that. For my tastes, the easiest way is to, in the hat, put 40 that say control group, put 40 that say swimming, put 40 that say weightlifting. Mix them all up, and then have the people each draw one out.
That makes a lot more sense.
That way you don't have to know anybody's name. You don't have to get personal with these people. I mean, they are subjects.
Yeah.
Okay, experimental units.
Yeah.
All right.
Guinea pigs.
So there's more than one right way to do this, but you do have to think through what it is that you're going to do with them. The other thing you could do is, instead of doing one of this, one of that, one of the other thing, you could go, I'm going to pull the first 40 names out, and you all go to, if they're mixed well, then I can pull the first 40, and those first 40 are going to do weightlifting, and the second 40 are going to swim, and then everybody else just go home, sit on the couch. Okay? That works also. So frequently there's more than one right way to do this. You know, you could get crazy and have, 40 yellow marbles and 40 red marbles and 40 white marbles, and everybody reaches in, and then, it doesn't say what you're going to do, but then you tell them, if they get a red marble, they do this. You get the idea. But it's got to be some way that randomly assigns the treatments to everybody. All right? Which way do you guys want to do it? I don't really care.
Let's go with everyone draws.
Yeah.
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 Everyone draws and it tells them what they're going to do?
Yeah.
Okay.
That is a good one.
So, take 120 equally sized pieces of paper And on 40, write weightlifting. On another 40, write swimming. And on the last 40, write, oh, what do we probably don't want to tell them you're the control group. Rest. Put all 120 pieces of paper in, oh, let's call it a container. You can call it a hat if you want to.
My experiment was
It's got to be a pretty big hat if it has 120 pieces of paper in it. And mix thoroughly. Have each participant select, without looking, a piece of paper and assign them to that group. All right, so then we need to have the participants participate. In that activity. For a set length of time. They didn't tell us how long we had for this. What do you think is long enough? 3 months? 6 months? 3 weeks? 5 days? What do you think?
Yeah, I'll say 6 months.
6 months? Okay. At the end of this time, evaluate all participants for depression. And evaluate by group. All right, so can we make this single blind? So let's start with the participants. Can they be blinded? Yeah, they know what exercise they're doing.
Yeah.
So the participants can't be blind. But who else is involved in this?
The experimenter.
So if I'm running the experiment, but I'm not doing anything else, does it hurt for me to know anything? Am I able to, in any way, as long as I'm not interacting with these people? Who else is interacting with the people, though? Who's evaluating for the depression? Somebody is, right? Would it be important that they don't know which group these people came from?
Yeah.
Right? You don't want the evaluator to know because they may have a personal bias. Okay? So, to make this single blind, do not let the people evaluating for depression who is in which group. And this cannot be double blind. Now, because this cannot be blind for the participants, what is it that you can't have in this? Since the participants aren't blind to the treatment that they're getting. You can't get the placebo effect, right? The people who are sitting on their couches know that they're sitting on their couches. Okay? All right, let's go on to the back. After completing your experiment, you become somewhat convinced that swimming may be helpful in preventing depression, but you're concerned that the effects may be different between men and women. Redesign your experiment to account for this and to hopefully further the claim in question using 120 new volunteers, 70 men and 50 women who are not currently involved in an exercise program. Now for this one, I probably, now that I'm somewhat convinced, I'm probably not going to do a control group at all. Okay? I'm just trying to find, is swimming better than weightlifting? And on the last one, if you didn't do a control group for that, it's probably okay because it's not levels of a treatment. If there are levels of a treatment, you pretty much always want to have a 0 level of the treatment. So, what are we going to do now? Okay, but how are you going to do that? Because you can't put right. We'd like to probably have an equal number of men, weightlifting as there was swimming, and probably an equal number of women that are weightlifting as are swimming. So how can we do that?
Have the men draw from a hat of 70 with one of two options, and then women draw from a hat of 50.
Yeah, that's exactly right. You're going to do 2 different draws. So we will use, to save ourselves from writing, paper in a container as in the previous explanation, but do 2 separate assignments. One for men with 35 pieces of paper each, marked with swimming or weightlifting. And one for women. With 25 of each type. So the way you would draw a diagram for this would be something like this. Then 35, 35, swimming, weightlifting, and then we're going to evaluate these for depression. And then do the same sort of thing for women, except it's just 25 of each. And then we would compare the groups to see, well, is there a difference? Maybe swimming in men helps but with depression, but swimming in women doesn't. Okay, so there's all kinds of interesting things that can happen with this. All right, questions? Okay. Well, that's it for today's lesson.